Now we are going to do example number 4. I want to switch the order of subtraction, switch the order of division. Notice how I didn't mention about what if you switch the order of division earlier? Right, let's do that. What happens if I have 6 divided by 15 instead? And as you can see right now, you have a smaller number divided by a bigger number. Okay, we are going to follow the same steps. Make sure that you put the first number inside, right? So we are going to use the long division. 6 is the first number, you put that inside. 15 is the second number, you put that outside. So as we can see that 15 and 6, well, 15 goes into 6 0 times. So if you just put 0, 0 times 15 is equal to 0, and you pretty much didn't do anything, right? Well, of course, you want to kind of keep producing some of the answers. So we're going to use the similar idea of what we did earlier. 6 is equal to 6.0, right? So let's do that as the first step. So for the 6, I'm going to add a decimal point, and then I'm going to put a 0 right there. Now we have 15, and I'm going to look at this as 60. 15 goes into 60 4 times. So I'll put a 4 right here. 4 times 15, you get 60. And when you subtract 60 minus 60, you get 0. When the remainder is equal to 0, that's the answer for sure. That's all. And then, don't forget, that's the decimal point. Also line up the decimal point for your answer. 6 divided by 15, you get a very different answer, 0.4. So notice 15 divided by 6, you get 2.5. 6 divided by 15, it's equal to 0.4. So a big note right here. The order of division, the order of division also matters. Just like the subtraction. So when you are doing division, you have to be really careful with which number goes first. And again, notice how we have whole number divided by whole number, but we end up with a decimal number, right? And whole number divided by whole number, you end up with a number that's less than 1. This is the beginning that we are going to study decimal numbers. Okay? And I will do a few more examples. As I said, division is a very tricky calculation, and introduce a new concept, the decimal numbers. Right? Earlier, when you multiply, when you divide, if you have whole numbers to start off with, you will always end up with whole numbers, but not for division. Okay? So, example number 5. Let's do 11 divided by 8. Long division again. Our good old good old friend, right? Long division, put the first number inside. I have 11, and put the 8 outside. 8 goes into 11 once. 1 times 8 is equal to 8. Subtract 11 minus 8, we get 3. Well, do you want to keep going, or do you want to see some decimal numbers? Then let's do it with decimal numbers. Okay? Otherwise, you can just say the answer is equal to 1 with a remainder of 3. But I want to see how to deal with decimal numbers. Okay, we love decimal numbers. Let's do it. So again, I'll make a note right here. 11 is equal to 11.0. I will use this concept. I will put a 0.0 right there. And then this allows us to bring down this 0 to here. And before you go on, you can put the decimal points right here already, right? Before we forget to line up the decimal at the end, you can put a decimal point right here already. 8 goes into 30 3 times, right? I think I'm right. 3 times. 3 times 8 is equal to 24. And again, subtract. 30 minus 24, you get 6. So put on the 6. Unfortunately, we still have remainders, right? So let's expand this idea. 11.0, I can write that as 11.00. It doesn't matter how many zeros that you add after the decimal point. It doesn't change the value. So 11.0, I'm going to add another 0 right there, and then I can bring down this 0 here to make that a 60. Right? I'm looking at this number as a 60. 8 goes into 60 7 times. So put a 7 right here. 7 times 8, we get 56. Again, you subtract. 60 minus 56, you get 4. Well, we still have a remainder. Guess what? We can just keep adding the 0 right here, and then we can continue this process. Let's try one more. 11, it's the same as saying 11.000. So I can add another 0 in the back. And I can also make the long division a little bit longer, right? Anyways, bring down the 0 down here. So instead of the 4, I am looking at this number as a 40. 40. 8 goes into 40. Exactly 5 times. 5 times 8, you get 40. And when you subtract 40 minus 40, well, yay, we get a remainder is equal to 0. So we are done. That's the answer. 1.375. The answer is 1.375. I really wish that to ask you guys to see if I have any questions, because that's what I like to do when I teach your class. But if you have any questions, just leave your question in the comment, and I will try to answer that via YouTube comments. Anyways, we did 11 divided by 8. Let's switch the order again for question number 6. Example number 6. Example number 6. I want to do 8 divided by 11. Draw the long division symbol and think about what number to put inside. Okay, and what's the rule? Remember, it's always the first number that goes inside. So put down the 8 and then put down the 11 outside. 11 goes into 8 0 times. So you put on 0, and that's pretty much all we can do, right? But again, we want to keep going. So notice that 8 can be written as 8.0. So use this idea. I'm going to add a decimal point and a 0. And if you would like, put the decimal points right here already. Line up the decimal points. Now we can look at this as 11 and 80. 11 goes into 80 7 times. 7 times 11, we get 77. And when you subtract 80 minus 77, you get 3. Well, I want to keep going, so I'm going to look at this as 8.00. So put on a 0 right here, bring down this 0 here. 11 goes into 30, 2 times. 2 times 11, you get 22. And subtract. 30 minus 22, we get 8. Well, I want to keep going because the remainder is not 0 yet. So, I'm going to look at 8 as 8.000. I'm going to add an additional 0 right here in the back. Bring this 0 down here. 11 goes into 80, again 7 times. 7 times 11, we get 77. And you subtract 80 minus 77, you get 3. And you cannot see a pattern. I'm going to add another 0 again. 8.0000. Use this idea here. I can attach another 0 in the back. Bring this 0 down here. 11 goes into 30 twice. 2 times 11 is equal to 22. When you subtract 30 minus 22, you get 8. Well, as you can see that it kind of like it never ends, right? Because notice that we actually have a pattern. It's 7, 2, 7, 2. And we see a remainder of 8 again. So the next number you know, it's going to be a 7, and then it's going to be a 2, and so on. And we can never finish this question. There's always going to be a remainder. So this is another reason that makes division more difficult than the others, because it looks like this question is never done. You can never finish this question. Well, let's talk about how many ways that we can actually say the answers to this. In this case, if you have 8 divided by 11, and when you see this happens, where the 7, 2, 7, 2, 7, 2, 7, 2, 7, 2, 7, 2 repeats, right? What we can do is, we can write this as 0.72, and let's draw a bar above the 7, 2. This means the 7, 2 are repeat. I'll say the digits 7, 2 keeps repeating. So the symbol 0.72 with a bar on the top, this represents 0.72727272 dot 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 dot. It keeps repeating forever. So this is one way to write the answer. 0.72 with a bar across the 7, 2. So let me bring back example number 5. So example number 5, when we're doing 11 divided by 8, we get 1.375. And then we actually were able to make sure that the remainder turned out to be 0, right? It only took us 1, 2, 3 decimal places after the decimal point to make sure to finish up this question. But if you change the order, if you have 8 divided by 11, you end up getting a totally different answer. 0.72727272. It's totally different compared to what you have originally, right? Example 5, you get 1.375, but example 6, when you do 8 divided by 11, you get these crazy repeating numbers. So order of division matters. Make sure that you have the right number inside. You have the first number inside. You have the second number outside. You must have the correct setup.